Right, we've worked with derivatives of the natural exponential function. Now let's look at integration. At the end of this lesson, you'll be able to evaluate an integral involving an exponential function. Alrighty, so we've got the integral, you'll notice, of e to the u. So basically what I'm going to be thinking to myself, what would I have to put here so that when I take the derivative, I will get e to the u. And we already found out in a previous video that if I have e to the u, when I take the derivative of it, I'll get e to the u du. So, and we'll just put plus c. So the e to the u is its own derivative and is its own integral. So a couple hints that I'm going to give you on these problems, because we'll work them just a little bit differently depending on what's going on in the problem. If there is one e in the problem, we will let u be the exponent. Okay? If there is more than one e in the problem, we're actually going to be letting u be a chunk, a bigger chunk, and I'll explain when we get to a few examples what exactly I'm talking about with saying chunk. All right, let's try something. Okay, this one I notice there is one e sitting in this problem. So to work this, even though it looks like a lot's going on, I'm just going to follow my hint. It said we're going to let u be the exponent. So let's let u be the exponent and just see what happens. Well, negative x to the fourth, there we go. Okay, so now we need to find du. The derivative of negative x to the fourth is negative 4x cubed dx. Notice we have negative 4x cubed dx, so we're actually all set to rewrite this problem. So we know we have done nothing with the e, so the e is still in the problem. This part right here, the negative x to the fourth, gets to be replaced with u, and then negative 4x cubed dx gets to be replaced with du. So now we know the integral of e to the u is just equal to e to the u. So my answer is just going to be e to the u. I'll sub my u back in, and then I am done. All right, let's take a look at another one. Okay, we've got e to the tangent x, secant squared x. Again, it looks like there's a lot going on in this problem, but if we just pay attention to the hint that I gave, if there is one e in the problem, we will always let u equal the exponent. So we're going to let u equal tangent x. Okay, so we need to find du, which means we're going to find the derivative of tangent. The derivative of tangent is secant squared x dx. And you'll notice, once again, I have secant squared x dx sitting right in my problem. So everything is all set up exactly how I want it. So if we go to rewrite this, I have done absolutely nothing with the e, so we need to bring it down. The tangent x we called u, and secant squared x dx became du. And now we know that the integral of e to the u is just e to the u, and we can sub our u back in, and then once again we are done with that problem. Alrighty, next one. Now this one kind of looks like, again, like it's got a lot going on in the problem. I'm going to use the hint. If there is more than one e in the problem, there are two e's in this problem, we are going to let u be a bigger chunk. So in this case, we're going to let u be this entire denominator. So we're going to let u equal 1 plus e to the 3x. All right, let's take the derivative. The derivative of 1 is just 0. The derivative on this one, this would be like an e to the u. The derivative of e to the 3x is just e to the 3x, but then we have to multiply by the derivative of the 3x, which is 3. So this will actually be 3 e to the 3x dx. And now if I look at my problem, notice I actually have e to the 3x dx. I'm just missing the 3. So I'm going to put a 3 on the inside, 1/3 on the outside. So I'm going to have 1/3. And then if I replace my information, 3e to the 3x dx is actually du. And then the denominator we actually called u. So notice now we have 1/3 the integral of du over u. Using formulas from a previous video, we know that the integral of du over u is equal to the natural log of the absolute value of u. So I'm going to bring the 1/3 down. So now just rewriting, I'll have 1/3 natural log of u, which was 1 plus e to the 3x, and then plus c. All right, let's try another one. Once again, you'll notice that I have two e's in my problem. So I'm not going to let u be an exponent. I'm going to let it be a bigger chunk. Okay, the bigger chunk that I'm going to let it be, I notice that I do have something in parentheses, so that's exactly what I'm going to let my u be. We're going to let u equal 2e to the x, and then just see what happens. All right, so the derivative of 2e to the x would just be 2e to the x dx. I notice I have e to the x dx. I would like to have 2e to the x dx, so 2 on the inside, 1/2 on the outside. So let's just see what's going on here. The one thing I have done absolutely nothing with is the word sine, so we're going to bring it down into my problem. The 2 to the ex we called u, and notice 2e to the x dx we turned into du. So now from here, we are looking for the integral of the sine of u, and we learned a while ago that the integral of the sine was actually negative cosine of u, and now we just need to put our u back in. So we're going to have negative 1/2 cosine of 2e to the x, and then plus c. So hopefully now you can take the integral of a function that involves e to the x.